Welcome to lecture series 8051 microcontroller. In today's session we will discuss about interrupts in 8051. Already we have discussed some lectures about 8051. 8051 is a 8-bit microcontroller which is the basic to design the embedded system. For any kind of specific applications we can select the 8051 microcontroller than 8085 microprocessor, because the microcontroller having some inbuilt functions like timer, interrupts and some memory. That is why we are preferring for the specific applications, any kind of system based applications we can select microcontroller than the microprocessor. Now we will discuss what is interrupt. Okay. Interrupt means it is a external disturbance. Okay. So controller already doing some parallel processing. At the same time, any one of the peripheral devices or external devices want to do some functions with the 8051. If any one of the peripheral device or external device want to access with the 8051, then it will raise the signal that is called as the interrupt signal. After getting the interrupt signal, the controller temporarily suspend its work and switch over to the specified function. Okay, what it need. Suppose it want to load any data, or it want to read the data, or switch on or off, whatever the peripheral need the specific conditions, that time the peripheral devices raise the external request. Okay. So the external requests are raised by the peripheral devices, that is called the interrupt. Then after getting that request, the controller suspend its current work, then switch over to the specified routines, because it assigns some subprograms or subroutines. Whenever any one of the interrupt is occur, then it has to do the specific functions. So based on that, it will switch over and it complete its work. Okay, that's why the interrupt the controller. Its current work is suspended or disturbing the controller. That's why we called. Okay. Okay, what are the interrupts are available in 8051? It has two kind of interrupts: internal interrupt, external interrupt. External interrupts mostly activated by the hardware, peripheral devices. Peripheral devices, whenever the request is occur, then it will perform it. So for that, the 8051 has two interrupt signals which are INT0 and INT1. These two are which is available in the port 3. Okay. So based on that, either any keyboard or mouse, whatever the peripheral devices can be connected with this INT0 and INT1. It has a specific subroutines. Whenever the request is raised, then it will suspend its current function, then switch over, then it will execute its corresponding function. So its subroutine, interrupt subroutine is a subprogram, right? That will be terminated by using the IRET instruction, that is return interrupt. After reading that instruction, it will be terminated from the subprogram and written. Then now the microcontroller will do the regular works. So for that, it has two interrupts which are external interrupts. Then three software interrupts. Three software interrupts means what it indicates during the execution of the program. If any abnormalities or if any specified condition is occurred, automatically it send the interrupt signal to the controller. Okay. During the execution of the sequence, if any interrupts are raised, then it is called as a software interrupt. Due to the peripheral devices, the request is raised, then it is called as a hardware interrupts. Okay. So by the software, it has a three kind of interrupts based on the timer T0 and T1. Okay. Two timers are available in 8051. Whenever the timer starts, it automatically started to increase, right? When the level signal is varied from 0 to maximum value. After reaching the maximum value of FF in hexadecimal, then after FF it goes to the 0 value, right? When it goes to 0, what happened? The overflow is occurred. Now the counter or the timer is restarted. So during that time, the overflow is occur means it interrupt the controller. It will raise the interrupt signal. Already discussed in the timer flock. Okay, the TF0 and the TF1 is available based on the modes of operations. Whenever the counter is overflow, then it will activate. The another one is third interrupt is TI and RI, right? TI is a transmitter interrupt, RI is a receiver interrupt. So at the same time, we can either transmit or receive. Okay. So only one interrupt is considered as a single. This is a serial interrupt, you can say, that will be either a transmit interrupt or receiver interrupt. During the transmission interrupt will rise. During the receiving, the receiver interrupt will be rise. So these two interrupts will be activated by using the SBUF. SBUF is one of the special function register, which is a serial buffer. Okay. In the serial buffer, when it is full means it received the data. During the receiving, it has filled with the data. So after filling the data, it will interrupt the processor to read the data. So once the controller read it from the buffer, now the buffer become empty. So empty means what it represents, it ready to receive the next consequent bytes. Okay, that's why it interrupt the controller to take over the data, otherwise it will be overlap. So to avoid the collapsing of the data, it has to take it. So how it will identify means 8 bits are loaded. At the reading of stop bit, the RI will be raised. So it will interrupt the controller. Okay. During the transmission, what it indicates, from the controller we are loading the data. So we are loading means now SBUF is full. Then after it started to transmit, each bits are transmitted because this is a serial communication. So the data are transmitted bit by bit. Okay. So during that, after transmitting the 8th bit, the next bit is called it as a stop bit. So during the stop bit transmission, now it will activate the TI. TI is a transmit interrupt which will connect it with the controller. Now controller will understand the given data is transmitted. Now the buffer is empty. It is ready to transmit the next data or next byte. Now if you have a consequence of byte, then the controller will load the new data in the SBUF. Now the SBUF will start to transmit. So this way we are using without avoiding any data collapsing or colliding. We can transmit and receive with the help of the SBUF. Okay. Now we will look into each interrupts in detail. So external interrupts which are INT0 and INT1, which are connected from the port 3. The internal interrupts TF1, timer overflow for the timer 1. This is the timer overflow for timer 0. So T0, T1. Then this is a serial interrupt, which is a transmit interrupt and receive interrupt. So you can easily name it as 2 external interrupts and 2 timer interrupts and 1 serial interrupts. So totally 5 interrupts available in 8051. Along with that, how the interrupt functions are activated. Whenever you are interfacing with the peripheral devices, automatically some control word is needed. That control word is here is called it as a special function register. Some group of special function registers are available. Now we will check what are the special function registers available for supporting the interrupts. So in 8051, we have 2 kind of special function registers. One is interrupt IE register, another one is IP register. IE register is interrupt enable register, IP is interrupt priority register. So by the name you can get it interrupt enable register. What it represents, this is one of the control word which is used to enable the corresponding interrupt, because we have 5 interrupts, right. So what are the interrupts you want to activate, then you can activate, remaining you can disable it. Okay. So based on that conditions, this register will support what are the interrupts to be activated, what are the interrupts to be deactivated. So that by this way we are enabling the interrupts, that is why this register is used. Then another one is IP. So IP is interrupt priority register. What it indicates, we have 5 interrupts, at the same time 5 interrupts are active. Okay, that is enabled. Then all will raise the interrupts to the microcontroller, but microcontroller can perform the action for only 1 interrupt at that time. So that time the microcontroller will get a confusion which interrupt to be performed. So for that we are assigning the priority. So based on the priority, now the microcontroller will start to perform which has the highest priority, that will be considered first, then next highest level. So based on that it will assign. So we will discuss in detail. These 2 are 8-bit register. Now we will check the 8-bit format of interrupt enable register. Interrupt enable register, which is a 8-bit format. Out of 8-bit, 6 bits are used. The first one is EX naught, which is used to represent INT naught, external interrupt. If it is 1 means we can enable the interrupt, if it is 0 we can disable the interrupt. Okay. So, we can enable or disable the particular interrupt. Suppose if INT naught is applied with 0 means this will be disabled. If suppose any one of the port is connected with the INT naught, okay. So, when this pin is suppose you want to disable the USB access means here you can give the value of 0. If you are giving 0, automatically that port will be disabled by the software we are deactivating. Then this one is a timer, timer 0. If it is 1 means we can enable, if it is 0 means we can disable the particular interrupt. Okay. Next one EX1, which represents INT1. This one is timer 1. This one is serial, enable serial port. Okay. So, these are the 5 interrupts which we are using most frequently in 8051. This ET2 is not used. Okay. Then this is a master control which is enable all. Enable all. Okay. So, when it is 1 means all interrupts are enabled. When it is 0 means no interrupt. This is the overall control. Okay. If you are giving 0 here, the remaining interrupts are 1 or 0 means there is no meaning for that, because the overall interrupt is disabled. Okay. So, at the time it will not accept any kind of interrupts. Suppose if you are giving 1, remaining are 0 means that also good. If any condition is occur, at the time it automatically turn into that. Okay. So, this 8th bit should be 1, then based on the available of the interrupts you can activate. If suppose I am asking you to enable the interrupt, serial interrupt. Okay. So, enable the serial interrupt means what you will do, the serial interrupt should be 1, remaining interrupts are 0 0, right. This is not used, so you can put 0. At the time the 8th bit should be 1, which indicates it enable all interrupts. Okay. Now, what is the word 90, 90H. This is a control word which is to activate the serial interrupt. So, how we are activating means move IE, 90H, IE, 90H. What it represents? Now the serial port is activated. Okay. The same thing you can repeat it for, suppose you want to activate the external interrupts both. So, both interrupt means what you will do, INT naught and INT1. So, both are 1, at the time remaining all are 0, but the overall interrupt should be 1. Now, read the hexadecimal value which is 85. So, instead of 90, if you are giving 85H, what it represents? Now, both external interrupts are activated. Okay. So, now we have activated the external interrupt which are INT naught and INT1 by giving the control word 85H. Okay. So, this is a way we are activating the interrupt enable. The interrupt enable also bit access. So, you can give the directly, suppose you want to activate all the interrupts means set bit of IE dot 7. So, what it represents? This 8th bit is set it as 1. Next we will discuss about the interrupt priority register. Interrupt priority register which is used to assign the priority for the interrupts. Whenever the bit position is 1 means it represents it has the priority. If it is 0 means there is no priorities assigned. Okay. So, based on that, suppose I have assigned a priority for both external interrupts INT naught and INT1. Okay. So, now actually the controller will get a confusion which to be assigned first. So, based on the priority which has among the INT0 and INT1, which has the highest priority, that will be performed first, then INT1. Okay. So based on the priority it will be assigned. So we have to put 1 for all the interrupts. So if it is 1 means it is the priority assigned, otherwise not priority. Okay. So all the bit positions are 1. So the first one is for INT0, this is for timer 0, this is for INT1, this is for timer 1, this is for serial. If the bit position is 1 means it represents the corresponding interrupt is assigned with the priority, otherwise no priority. Now we will check which has the highest priority, how it will be assigned. Okay. So among this INT0 is the highest priority, then T0, then INT1, then T1, then either TI or I, any one of the serial interrupt. Okay. So these are the 5 interrupts. First highest is goes to INT0, or you can easily get this, the priority is from rightmost. Rightmost is the highest priority, then leftmost is the lowest priority. So now we have assigned the priority, based on that it will perform. Already I set it right. Suppose if you are assigning the priority, means what it will, both INT0 and INT1 is assigned with the priority. So 1 0 1 0 0 0 0 0. So the word is 05H. Okay. So now you are writing move IP comma 05H. So what it represents, the interrupts both INT0 and INT1 are active, and also I have assigned the priority for INT0 and INT1. Okay. So now both are activated at the same time. I have inserted one pen drive and one CD or another peripheral devices, or I have interfaced with the LED blinking, 2 sensors are connected. If any signals are sensed, then automatically it will raise the high signal on the INT0 and INT1. So at the same time both are sensed the signal and activated the high signal. Now the microcontroller will decide, first it has to perform the INT0, its request. Suppose sensor 1 is connected, means its request is serviced, then only it goes to the INT1. So during the service what it will do means, it all having the vector address. Vector address means once identified its request, the processor or the controller suspend its current work, then switch over to the specified address, means it is the starting address of the interrupt subroutine. So it has to switch over. Where to switch over means it has to know the address where to switch over. Now its vector address is 30003H. So this is the starting address of the subprogram, or you can say it is a interrupt service routine address. Okay. So now it have some set of instructions with interrupt return. So after request received from INT0, it goes to the address of 0003H. This ISR subroutine will started to execute one by one. Now after reading this interrupt return instruction, it will terminate its subprogram, then it will return back to the main function of the microcontroller. After that, now the INT1 will be serviced by getting the address of 0013. So these are the assigned address for the corresponding interrupts. Whenever the request is raised, then the controller will execute its corresponding subprogram. These are the subprogram addresses. Now we will discuss how the interrupts are overflow by the software, right. So this is a timer flag interrupt. So the timer flag interrupt will be activated by the TCON. So this is a TCON, one of the special function register assigned for the timer. So among this 4 is reserved for the interrupt, remaining 4 is reserved for the timer. So now we will discuss about the timer. The timer also operated in the 4 different modes. So these modes will define the size of the timer, that is either 8-bit timer or 13-bit timer or 16-bit timers. Okay. Now we are taking as a mode 1, which is a 16-bit timer. In the 16-bit timer you can use it either T0 or T1, both are the 16-bit registers, both you can initialize with some value, from that it will started to count. Okay. Suppose I initialize the value was 00, 00, this value is started, now it will started to increase, once it reach 0 then FF, right, this is the maximum value. When the value is changing from FF to 0, at that time the timer flag will be set. When the timer flag is set means automatically it is interrupt the controller 8051. So what it indicates, the timer overflow is occurred. So what is your condition? When the overflow is occurred, you want to switch over the functions, you can switch over it, or you want to repeat the same functions, we can do it. Okay. So according to the user requirements, we can assign the corresponding function. So for that the timer flag interrupt is assigned. So in the 8051 we have a 2 kind of interrupts for the timer, T0 and T1. It will be activated by the 4th and 5th bit or 6th and 7th bit. These all are bit accessible and also byte accessible. So you can read the corresponding overflow flags. Okay. So this is a way. In each mode, in case of mode 0, it is for 13-bit. So whenever the 13-bit is overflow is occurred, all 1s to 0, then its corresponding timer overflow will be sensed, TF flag will be set. In case of mode 2, it will support only for 8-bit. So whenever the bits changes from FF to 0, at that time it will, the TF will active and corresponding function will be executed by the controller. The another one is a serial interrupt, which is activated by the SCON register. In the SCON register is a 8-bit register, which is a serial control register, which will give the control informations about the serial communication. So for that it has a 8-bit data. So among the 8-bit data, 2 bits is reserved for the interrupts. One is for transmit interrupt, another one for receiver interrupt. The next 2 bits is reserved for the frame size, either 8-bit or 9th bit of informations. This is a receiver enable. This is not used. These 2 are reserved for the modes of operations, because in the serial communication also supporting the 4 different modes of operation. These modes of operations will define whether shifting mode or the frame size, either 8-bit or 9-bit. Okay. So that kind of informations will be given in the serial control, because during the reading operation, based on this only it will understand how many bits are available and where to load. Okay. If suppose I have selected the mode 1 means it is a 8-bit mode. 8-bit mode means what it represents, 8 bits are information, along with that 1 start and stop bits are added. So totally we are giving as a 10 bits. 10 bits are the frame size. First bit is the start bit. So after receiving the start bit, that will be discarded, remaining after that, followed with that, the 8 bits are received and stored in the SBUF. Then followed with that it will receive the stop bit. During the stop bit it will activate the, in case of receiving it will activate RI. So RI activate means what it represents, the 8 bits are received which is available in the SBUF. Okay. Now after activating to the interrupt of 8051, now it will activate the read signal to read the data from the SBUF. So after reading that, now it become the empty. So this way only we are performing the read operation. After transmitting of 8 bits during the transmission of stop bit, okay, now we are transmitting the data bit by bit, first start bit, then 8 bits which are reading from the SBUF and started to transmit, while the transmission of the stop bit, it will activate the TI. Once the TI is activated means what the controller will do means, now the buffer is empty, okay, the new data will be written into the SBUF by activating the WR bar. WR bar is a write operation which is used to write the data. Okay. So, this is a way during the read and write operations of SBUF, the TI interrupt and RI interrupt will be activated. These external interrupts will be activated either edge triggering or level triggering. Edge triggering means the level changing from high to low or low to high. So, this level high to low, which is called it as a negative edge triggering. The level changing from low to high is called it as a positive edge triggering. So, any one of the edge triggering or the value changes, this is a low high level, this is a low level. So, during this period when the interrupt is started to activate, this is called it as a level triggering. Okay. Either we can use this kind of activations or this kind of activation. This is a level triggering, this one is the edge triggering. So, how the circuit is used to activate? In case of INT naught, which is connected with the pin number 3.2, okay. So, either the switch is 0 or 1. If it is 0 means it will pass via the level triggering. If it is 1 means it passed via the edge triggering. Okay. So, via the edge triggering, this interrupt will be activated. Anyhow, the same subroutine is executed. The same thing is repeated for INT1 with respect to the pin of port 3.3. Okay. The same buffer is used for generating the level triggering. Then here a pulse which is used for identifying the edge triggering, which is activated in the interrupt enable with the TCON 0.3. Either you can use with the interrupt enable 1 or TCON. Okay. The timer control also having the 4-bit positions to activate the external interrupt, either edge triggering or not. If it is 1 means it will activate. Okay. So, reset also one of the interrupt which will clear. Once you are pressing the reset means what it was doing, it was internally clear all the registers. What are the registers are clear means first the program counter, because like erasing the board for taking the new topic, here before starting the new program you are pressing the reset button which will clear the program. After typing the program also you are resetting, then only you are giving the starting address of the program to execute. So, during that time what are the functions are performed within the controller means the program counter is cleared, the program data pointer is cleared, accumulator, base B register, then the stack pointer is initialized with the maximum address, the program status word is cleared, all special function registers are cleared. Okay. So, these are the functions you have to know internally, these are cleared. Now, whatever you are giving that will be loaded into the corresponding registers. Now, one simple program, write the instructions to enable the serial interrupt, timer 0 interrupt and external hardware interrupt. Okay. So, how you can write it? The serial interrupt should be 1, then timer 0, then external hardware 1. So, these are the bits to be 1, remaining are 0. Okay. So, by the instruction also you can write the program set B IE, this is a IE, right, IE7 which is a interrupt enable, then set bit of IE dot which is a serial port. So, you can give it as 4, then set bit of IE dot 2, then IE dot 1. So, by this way also you can activate the corresponding interrupts, or you can give move IE comma, what is the its equivalent hexa words, you can write 96. So, you can load it a 96H. Okay. So, either by a single instructions you can activate, or by using the bit access you can use it. So, how to reset the serial interrupt? Serial interrupt, either you can give the control word, otherwise the corresponding bit position CLR, right. What is the corresponding bit? IE dot 4. Okay. So, by giving this instruction the corresponding serial interrupt will be reset. Suppose you want to deactivate or disable all the interrupt means what kind of instructions you will use it? Yes, CLR, right, the corresponding special function register interrupt enable dot the corresponding bit position. By using this, among the 8 bit the last bit is 0, right. If it is 0 means automatically all the interrupts will be disabled. So, these are the ways we are using to disable the interrupts. In today's session, we have discussed how the interrupts are activated and what are the interrupts are available in 8051, right. Then what are the special function registers will support to activate the interrupts. At the same time, more kind of interrupts are activated, then how the microcontroller will handle this kind of interrupts by assigning the priority was discussed on today's session. Hope you have enjoyed with a clear understanding. Thank you.